Okay, so we're gonna finish up 4.2, so I called it 4.2B. It is just the two application of the two word problems, all right? And then we're gonna do 4.3. Remember, if you think of a question, to ask it, because you are being recorded and that person's not here to ask their questions. Okay, so here is example 2 and 4.2. We skipped it. So I'm gonna read it to you, and then I'll draw you a picture. Down here, you're very familiar with this kind of stuff. Okay, the Tacoma Narrows Bridge in Washington has two towers that each rise 307 feet above the roadway and are connected by suspension cables, and they gave you a picture. Okay, so here's my road, all right, and then you have these two big giant towers. Obviously, they go down into the river or whatever you're going over, all right, and from each end. Okay, and they did tell me that they were 307 feet above the roadway. Not total height, but just above the roadway. They said they were connected, or the road was held up by suspension cables. So this is like, is that what y'all call the Memorial Bridge over there right beside the Rainbow Bridge?
Yes, ma'am.
Is that right?
Yes, ma'am.
Okay, so this is very much like the Memorial Bridge. It's a suspension bridge held up by these big giant cables. Each cable can be modeled, that's these big ones right here. Each cable can be modeled by this equation. Y is equal to 1 over 7,000 times x minus 1,400, quantity squared, plus 27. Okay, that's a 7. Now, here's what they want to know. Where x and y are measured in feet, and they want me to find the distance d between the two towers. So that's what they want to know. What's d?
So
What? Tell me.
when you say the first horizontal, like this side, would you say that's the y-axis?
Oh, you could. That'd be very beneficial.
And when you say the road is the x-axis?
Yes.
Okay.
Okay. So
If the
here's what Hayden said. He said, this is my y-axis, okay? You could do it that way, and this is my x-axis. That's what his brain's kind of telling him, okay? So, now what?
So the vertex is the midpoint.
Oh, so my vertex right there is going to be the midpoint halfway between these two things. Do you agree? What is the vertex?
Oh, 14, or 1,400.
1,400.
27.
27. Okay, so what does this 1,400 represent?
Half the distance.
Yeah, this is half the distance, and what does the 27 represent?
The height.
The height, how far that cable is up off 27 feet above the roadway, and this is 1,400. Well, guys, if from here to here is 1,400, what's from here to here?
1,400.
So what is D?
2,800.
2,800 feet. I mean, we didn't even have to really do any math, but you did have to know about parabolas and stuff like that. I will say this, I'll do a tad bit of a disclaimer. I'm glad Mr. Ryan didn't walk by, because had Mr. Ryan walked by, he would have balked at them calling this a parabola. It's actually, I can't even remember what the name of it was. It's called a catatonic curve. It's a cata something, C-A-T something. But anyway, it's not actually a hyperbola, a parabola, but it does look like one, and they are saying that it follows this, so we just went with it. Okay? All right, here's the next one. Example 4. Remember, these were just the 2 reading problems.
What's
Toward,
the difference between that whatever curve and a parabola?
there's not a whole lot of difference, but there is some difference. And when you loop something like this, then that is what it's called. And I don't really know, because that's really calculus, and that's when you talk about those kind of curves. It's been 900 years since I took calculus, but that's what it does. And it maybe have something to do with the way it rises, and because it's stopped at this point right here, and that makes it hang a little bit different instead of going up like you would think it would. But they're saying that this part of the curve follows that equation, so we just went with it. All right, so here's number 4. This is the next one. Here's what it says. The path of a place-kicked football can be modeled by this function. Y is equal to negative 0.026 x times x minus 46. Okay, where x represents the horizontal distance, and it is in yards. Y represents the height, and it is also in yards. Okay, the path of a place-kicked football. So a place-kicked football is a football that's put on. That's when they kick those after at the beginning of the game, at the end of, or at the beginning of the 3rd quarter, and anytime someone scores a touchdown, then the other team kicks a place-kicked football. Okay.
So it goes up and then it goes down.
Yeah, that's exactly what it does, okay? So, like if your little guy ran up here, that's what they're gonna do. They're gonna run up here, and this is gonna be your football. Then when you kick it, it's gonna do this, which is gonna make a parabola, all right? So, that is my place-kicked football. They're telling me that this is the path that it takes, okay? So, this is a quadratic. Is this a quadratic?
Yes.
Yes, when you distribute this right here, you'll get an x times an x, and you'll get an x squared, okay? Now, I'm gonna show you something, because this is kind of written a little bit weird, because it just has that x. So, let me show you another way. Sometimes you can write it, and some kids will get it if I just do this. Okay? And some kids are like, whoa, wait a minute. That's still not what we've been talking about, Miss Davis. So then, watch what I'm gonna do. 0.0026. This is my A. Do you agree with that?
Yes, ma'am.
Okay? And this negative means that my parabola opens how?
Down.
Down. And this number that's between 0 and 1 tells me that my parabola is,
Very wide.
yeah, it's very wide. All right? And this is just a plain old x. What could I subtract from x and still get x?
Oh,
What can I subtract from x and still be equal to x?
0.
0. So you could write this little factor right here as x minus 0, okay? And then this other one would be x minus 46. Now it looks like the intercept form, okay? It looks like the intercept form. Look, think about this. What are my x-intercepts? 0.
0 where it starts, because it would be in quadrant 1.
That's exactly right. 0 is where it starts, and then this is 46, which tells you what?
It ended there.
Yeah, it stopped. That was the next time it hit the ground. Okay, so that was how far it was actually in the air, kicked in the air. Okay, now it can roll and they'll take it and let it go farther, but that's how far it went in the air. Okay, so here's what they're asking me. They want to know, A, how far was it kicked? Okay, and we know that, right? Because you just answered that, so what's that?
Oh, 46.
Yeah, that's your 46. That's your 46 yards, okay? Here's, see my X-intercepts are 0 and 46, okay? And, this is where it started, and this is where it ended, okay? B wants to know what is the maximum height. Okay, what is the maximum height? Now, where is the maximum height going to occur on this curve? What is that point? That's exactly right. So that is my vertex. Destiny said we've got to find the vertex of this parabola, all right? So how do you find the vertex? Well, you remember that h is equal to p plus q divided by 2. So that's going to be 0 plus 46 divided by 2. 46 over 2 is 32. Is that my height?
Miss Davis, it's not 32.
Oh, it's 23, sorry. Got a little dyslexic there. All right, so 23, thank you. Nothing's working good for me. Okay, so 23, is that right?
Yes.
Yes? Is that my maximum height? What is that?
No, that would be the
Your X.
half difference.
That's my x. So that is the distance that it travels, and yes, it is halfway, before it, when it reaches its maximum height. So what am I gonna do with that to find my maximum height?
Look at this.
Yeah, I'm gonna plug it in my equation. This is my h, my x value, and I need to find my k. Okay, so k is equal to, I'm plugging this 23 back in this equation right here. So I'm gonna go negative 0.026 times 23 times 23 minus 46. Okay, so I'm gonna pull my calculator out. Now look, if I ask you to do some of these problems on a test, you probably would need a calculator, okay? So, negative 0.026 times 23 times parentheses 23 minus 46, close the parentheses. And so there it is, 13.754, and it is yards, okay? So that is my maximum height. Is that reasonable?
Yes.
Yes, that is reasonable, okay? It is reasonable. The goal when you kick a football is to not just kick it far, but you need to kick it high enough, not too high, but high enough so your guys get a chance to get down there so they can tackle the guy before he runs far, okay? So you gotta have some stuff in there. You gotta have a little bit of height to give your people time, but you don't wanna just kick it all up high and then have it come down right there, because then they get it if they call for a fair catch and you can't tackle them. Okay? All right. Something that you need to know that's very important. Write this down. X is the value where the min or max occurs. Okay? Or you could think of it as what gives you the min or the max. Okay? Why that value is the minimum or maximum. Okay? So the y value is the actual minimum or maximum. Like here it says, what is the max height? And the x value is where it occurs, or what will give you the minimum or maximum. Be careful about finding the x value and going, oh, there's my min or max. No, you gotta plug it back in to get your min or max. All right, anybody got a question about that one? Okay, So, here's another problem. I don't know where this problem came from. I'm thinking it must have come from 4.1. But I don't know why it's laid out here, and it may be because we didn't do it.
So do all real life problems occur in quadrant 1?
Yes, because most of real life problems deal with time or distance or something like that, but they deal with positive numbers, not negative numbers. I think this must go with my 4.3, so I'm gonna put it back here. All right, so anybody got a question? No, everybody good? Okay, so we're fixing to move on to 4.3. Now listen. Yeah, that one goes with 4.3. All right, so 4.3, very, very important. 4.3, we are going to solve x squared plus bx plus c equal to 0 by factoring. Okay, so the easiest way to solve a quadratic, that's what this is because it has an x squared. The easiest way to solve a quadratic is to set it equal to 0 and factor it. Okay, so that's the first way that they teach us how to do it. Now, we are taking special ones. This one does not have a number in the 1. It has a 1x squared. It does not have a coefficient of the quadratic, anything other than 1. So when I factor these, like I can tell you point blank, this is how to do it. Once I put a number in front of this x squared besides a 1, factoring becomes very difficult. All right, so that's what we'll do next class. But right now, all we're gonna do is the 1. Because if you can't do the ones with the 1, you're really gonna struggle when I put a number. But that's what I'm gonna do on Wednesday, okay? Wednesday, I'm gonna put a number other than 1 right here, and the difficulty level can grow exponentially. It can grow really big fast. But it could be like not quite so bad. So right now, we're just gonna talk about ones. So when you are factoring, I don't care what you're factoring. Anytime you're factoring, the very first thing that you want to ask yourself is, can I take anything out? Okay? Is there a number or a variable that I can factor out of every term? If it doesn't come out of every term, I can't take it out. Okay? If you factor it out, it has to come out of every term. Notice that your quadratic wants everything on the left and 0 on the right. Okay? Everything on the left and 0 on the right. The second thing you're going to ask yourself, and you won't understand this until I'm going to work some problems first, and then I'm going to talk about the second one. Okay? So I'm going to say the best thing to do after you've asked yourself this is you can say, is it special? Okay? If it is special, we can factor it really fast. We don't really have to do a lot of thinking and guessing and checking and all that kind of stuff. If it's special, we can just write the factors down. Okay? So these are the first two things we're going to start off with. Now, we're going to leave this one off for a second, and we're just going to learn how to factor this with a 1. All right? So, example 1a. Here's my problem. X squared minus 9x plus 20. X squared minus 9x plus 20. So the first thing I'm going to do is I'm going to look at this guy and I'm going to say, can I take anything out? Does anything go out of 1, 9, and 20? No. And he doesn't have any x's, so I can't take any x's out. Okay? So I can't take anything out. Now, that means we're going to factor this like this, into the product of 2 binomials. All right? So I'll have 2 terms in this parentheses and 2 terms in this parentheses. That's why we call them binomials. What does x squared factor into?
X.
X and x, right? Now, this sign right here, yes?
Oh, well, you're probably about to answer it, actually. But I was gonna say, doesn't if it's a positive mean they're the same?
That's exactly right. That's exactly right. So this sign right here, look, this guy is gotten from the last times the last, all right? And if you want it to be a positive, then these two signs have to be alike. So anytime you see a plus sign right here, you go, oh, okay, I got like signs. And guess what, people? They're like this guy right here. So anytime you got a plus sign, you got two signs that are just like this guy, minus and a minus. Okay? Now listen, there are lots of ways that teachers teach factoring, okay? Because this is a pre-AP class, I teach it one way. If you don't get it this way, then you need to go talk to another teacher and get them to teach you a trick. But 99% of y'all are gonna get this way, okay? And I found it's the best way to teach because when I taught tricks, when I taught a regular class, then those kids didn't remember the tricks the next year. So then the next year when I had them, I was like, remember we did a trick. What trick? I don't remember that trick. But the kids that learned a skill, which is what I'm fixing to teach, then they knew how to do it because that was their skill, okay? So here's what I'm gonna do. I'm gonna list the factors. I'm trying to figure out what goes here and what goes here. So I'm gonna list the factors of 20. Okay, the factors of 20, the numbers that multiply together, that's what a factor is, that give me 20. So I just start from the beginning. 1 times 20. What about 2? Does 2 times something give me 20?
2 times
2 times 10. What about 3 times something?
No.
What about 4 times
Yes.
something? 4 times what?
5.
What about 5 times something?
Wait, why are you keep going?
Listen, what about 5 times something?
4.
5 times 4. So when they flip-flop like that, 4 times 5 and then 5 times 4, that means you're finished,
Oh.
okay? Or if they stack up on themselves like a 3 and a 3 for a 9, or a 4 and a 4 for a 16, all right? So that tells me I've listed all the factors. So I always keep going until I've listed all of the factors, okay? Now, this guy right here, this guy, he's what I call my cheater sign. He's gonna tell me what to do with these factors. This last sign says, hey man, find the factors of 20 that add to be 9. With 4 and 5, okay? So it doesn't matter where you put them because both the signs are alike. So I'm gonna put my 4 here and my 5 here, okay? Now listen to me. You always check the inners, negative 4x, and the outers, negative 5x. And there is my negative 9x. You always want to check the inners and the outers. Why do we not check the first times the first and the last times the last? Y'all, we made the factors of this. I said, who multiplies to give me x squared? And y'all said x times x. So I know they're right. We only listed the factors of 20. So I know these two have to multiply to give me 20. But there you can see that the negative times the negative will give you the positive. That's why you want these to be the same. Okay? Want to try another one? Yes?
Yes.
Okay. What about this guy? What if I give you x squared minus 8x minus 20? Okay? First thing I'm going to ask myself, can I take anything out? Can you pull anything out of all 3 of these terms? This is a trinomial. It has 3 terms. Remember that terms are separated by plus and minus signs. Okay? So can you take anything out of all of them? No. So that means he factors like this. What does x squared factor into? X and x. This time, I have a minus sign at the end. Now guys, listen, if you're going to multiply last times last and you're going to get a negative number, what do these two signs have to be? Different. One has to be a plus and one has to be a minus. When you multiply 2 numbers and their answer is negative, the signs have to be unlike. So we're going to go plus and minus. Now, I'm going to do the same thing again. I'm going to list the factors of 20. 1 and 20. 2 and 10, 3 and nothing, 4 and 5, and 5 and 4. Okay? What am I doing with my factors now? What does my cheater sign say?
You're subtracting.
I'm subtracting, and what do I want?
A negative 8.
And I'm just gonna talk about the number right now, okay? And I'll show you how to get the sign. Okay, so I want an 8. Who subtracts to be 8?
2 and 10.
2 and 10. Now, what kind of 8 do I want?
Negative.
So the big number has to go by the negative sign, and the small number goes by the positive sign. Always check your inners, plus 2x, and your outers, minus 10x, and there is that negative 8x that I'm looking for.
So if there would have been a negative sign on the x, can you take a negative out?
I would have, I'm gonna tell you, you mean a negative sign on the x squared?
Yes, that's
I'm gonna tell you this, I am never going to factor when that quadratic term is negative. I'm gonna take that negative out of everybody and push him out front right here. And the reason is, he messes up all these rules that I'm telling you,
Oh,
okay? He'll mess up all these rules. So you have to be very careful with that. So I'm just like, no, I like the rules are simple and straightforward. He says, the factors of 20 that subtract to be 8. He says, the factors of 20 that add to be 9. Okay, it's very straightforward. Now, as soon as I put a number in front of this, all that stuff's gonna go out of the window. Our plus sign meaning they're both alike and they're like the first one, and our minus sign meaning they're different, that stays. But now I can no longer play the game that I was playing. All right, so we'll do that. We're gonna do it next class. All right, so here's another one. X squared plus 5x minus 6. I'm gonna give you a chance to do it, okay? I'm gonna give you a chance to do it, so I want you to factor it. Okay, y'all got it?
yes, ma'am.
Okay, so nothing comes out, so I'm gonna factor in like this. X squared factors into x times x. What does the minus sign at the end mean?
They're different.
They're different, so one's a plus and one's a minus. Guys, listen to me. Do not come up to my desk with your paper looking like this and say, Miss Davis, I can't do this one. I'll be like, well, the reason you can't do it is because you've not written all your factors of 6. Now, does that mean that everybody in this classroom has to write their factors of 6? No. Some of you know what the answer is, so write the answer down, okay? But if you can't do it, you need a system to be able to work with. Do you understand what I'm saying? Okay? So, the factors of 6, 1 and 6. 2 in anything?
3.
And 3 in anything?
2.
So now that flip-flops, so I know I'm finished, okay? What am I doing with my factors?
You're subtracting.
Who subtracts to be a 5? 1 and 6. And I want a positive 5, so who goes by the plus number? These are the ones I'm picking. The 6 goes here and the 1 goes here. I'm checking. There's my positive 6x. My outers give me negative 1x. And there's my positive 5x that I'm looking for. Okay? This is one that's commonly missed. Why? Because what do you know about 2 and 3?
They give you
They
5.
add to be 5, okay? So some kids, their brain's gonna go, oh, 2 and 3 make 5, and they're gonna put them there. They do make 6 when they're multiplied, but when they're subtracted,
They give
which
you
that
1.
cheater sign, they don't make 5, they make 1. Okay? All right, you ready for one more, and then we're moving on. X squared plus 3x minus 12. Okay, you got it?
No.
I'm gonna venture to say that this is probably one where you should have written your stuff out right here, okay?
I did.
So, can't take anything out, so I'm gonna go X and X. What does the minus sign mean?
They're different signs.
Okay, so plus and minus, alright? And when I try to do it in my head, I go, whoa, wait a minute. Alright, so let's write it down. The factors of 12. 1 and 12, 2 and
6,
3 and anything,
4,
and 4 and anything.
3.
So I'm finished,
Yes.
alright? Who subtracts to be 3?
None of them. What? Oh, okay.
Not possible, okay? Not possible. Now guys, listen to me. This is just a matter of fact, right? There are none of these factors we listed. Every one that subtract to be a 3. When I put a number in front of here, it's not gonna be as point blank and in your face as this guy is. You're going to go, is this not possible, or can I just not do it? Do you see what I'm saying? That's what's gonna happen to you, all right? It's gonna be a little bit difficult. As we move on through the chapter, I'll show you another way to take this equation and figure out if it's not possible, or if you just don't know how to do it, okay? But first, we won't do that at first. All right, so let's talk about this special thing right here, because obviously it's important if it's the second thing I'm gonna ask myself, okay? So, there are 2 of them, and we're gonna call them special products, okay? Because products are things that you multiply. All right, so the first one, do y'all remember all this from Algebra 1?
Yes, ma'am.
Okay, good. So the first one is called, it has a special name, and it's called the difference. What does difference mean operation-wise?
Subtraction.
Very good. So this is the difference of 2 perfect squares. Okay? The difference of 2 perfect squares. So first of all, you have to be subtracting. If you're adding, it doesn't work. Okay? You have to be subtracting. How many terms am I going to have?
2.
2 of them. And they're both going to be perfect squares.
I don't get what
Okay.
you mean by that.
Huh?
I don't get what you mean by that.
Okay, so let's talk about that for a second. All right, let's talk about perfect squares.
I get what the same.
So a perfect square is 4.
Oh, okay.
Why? Because 2 times 2 is 4. A perfect square is 9, because 3 times 3 is 9. All right? Is 38 a perfect, huh?
It's like the difference of 9 and 4. Is that what that means?
No,
Wait,
it's like, is 38 a perfect square? Can you multiply one number times itself and get 38?
But wouldn't those cancel
No.
out the difference
Okay,
between those?
so hang on just a second, I'm gonna show you something. So the first thing I want you to understand is, guys, you should know all your perfect squares all the way to 15.
Oh, yes.
So let's see if you do, okay? So what's 2 squared? Talk loud. What's 2
4.
squared?
4.
4. 3 squared?
9.
4 squared?
16.
5.
25.
6.
36.
7.
49.
8.
64. Yeah.
9.
81.
10.
100.
11.
121.
12.
144.
13.
No.
That's where everybody stopped. All the classes, when we did them, they're all like so proud and they all go to 12. And then they're 13 and they're like, don't know. So here's the ones that you don't know that you need to know. Okay? So 13 squared is 169. Okay? Now watch this, guys. 14 squared, 196. Do you see what happened?
Yes, ma'am.
So if I know 13 squared is 169, I know the next one flip-flops those last 2 digits, okay? And 15 squared is 225,
Oh, I did know that one.
okay? So right now, that's where I would say you would be good to there. If you needed anything past there, you could always jot and play on your paper a little bit and figure it out, all right? But the problem is, if I'm going to recognize perfect squares, these numbers over here, okay, which like 2 squared is 4, 3 squared is 9, 5 squared is 25, 6, 7, 8, 9, 10, 11, 12, and then it goes right there, 13, 14, and 15. All right, so I have to be able to recognize these numbers right here, so that's why you have to know them, okay? So what does it look like? Well, obviously, it's going to look like something squared minus something squared. Do you agree with that? It's the difference of two perfect squares. Listen, I'm going to write it in words first, and I'm going to show you what it looks like. It always factors into this, the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. Okay, so what does this factor into? Well, what's the square root of A? Squared. What's the square root of A squared?
Oh, A.
A. Plus, what's the square root of B squared?
B.
Times, what's the square root of A squared?
A.
Minus square root of B squared, B. All right, now these two things, look at those two things. They have the same first term and the same last term, but the only thing that's different is the sign in between. Do you understand that? A plus B, A minus B. They have a special name. You need to know it. It's called conjugates. Conjugates, okay? The same first and the same last and a different sign in between. The same first and the same last, but a different sign in between. So let's just go over here for a second and see if you can name some conjugates, all right? What is the conjugate of x plus 6?
X minus 6.
X minus 6.
Oh, I see.
Now you know when you multiply these two, that the inners, a positive 6x, and the outers, a negative 6x, they cancel each other out. And you get the first squared minus the last squared. That's what this
I
is.
remember this.
You
now.
remember this? It's starting to come back to you. Okay, what is the conjugate of y minus 7?
Y plus 7.
Y plus 7. Okay, what is the conjugate of negative a plus 3?
Negative A minus 3.
Very good. So what's the common mistake? Why did I do that one? Because that one's missed a lot.
People change the negative sign.
That's exactly right. People change this sign and this sign. That's not, we didn't do that up here. We kept this first guy and we changed the middle guy's sign. Okay? So you're going to keep the first guy and just change this sign.
If you would have done positive A positive A plus 3, is that the same?
That would have been positive A plus 3.
Yes, ma'am.
That would have been A minus 3.
So are those two conjugates the
These
same?
are conjugates and these are conjugates.
But are
These two, no, these two are not conjugate. These two right here are not conjugate. They have to have the same first term. This guy's a negative A and this guy's an A.
oh, okay.
Okay? They are not the same term. This is owing $1 million. This is having $1 million. Okay? Not the same thing. All right? So, okay, so let's talk about the next one. Well, I'll tell you what, let's do this one really quick. Let's do some of these right here really fast and practice some. All right? So what if I told you it was x squared minus 25? X squared minus 25.
X plus 5, X minus 5.
Very good. Can't take anything out. As soon as I see two terms, my brain goes, oh, this could be special, right? This could be special. Make sure it's the difference of two perfect squares and not the sum. The sum does not factor, okay? And it always factors into conjugates. Square root of the first plus the square root of the second, square root of the first minus the square root of the second, okay? What about this one? 4x squared minus 81.
2x plus 9, 2x minus 9.
Very good. 2x plus 9 and 2x minus 9. Conjugates. Y'all, conjugates is going to come up 2 other times in this chapter, and then it's going to come up later on in the rest of the book. Okay? So this word right here is going to be said a lot. You need to understand what they're talking about. All right? So when you multiply conjugates, look what happens when you multiply conjugates. I'm like, oh man, those are conjugates. So the inners and the outers don't really even matter because they're just the same thing with different signs. So all it is square the first, 4x squared, minus, because look, those signs have to be different. That's what makes them conjugate. Square the last, 81. All right, so would it matter if I wrote this as 2x minus 9 times 2x plus 9?
No,
Why?
because they're the,
What property?
I guess.
Yeah.
Commutative?
Commutative property of multiplication, which says that the order that you multiply things in does not affect the end. Very good. Okay, so what's the second one? The second one, this one's a little bit harder to recognize. A lot of kids will not see this until they've already done it the hard way, and then they'll go, dang, that was a perfect square trinomial. I could have done that a whole lot easier, okay? So the point is not that you couldn't factor it another way, but that if it is this, I can factor it really fast, okay? So this is called a perfect square trinomial. So how many terms is he going to have?
3.
3 terms. Trinomial has 3 terms. The first one looks like this. A squared plus 2ab plus b squared.
Oh, I remember this one.
Okay? Now, look what we're looking for. Okay? You're looking for the first guy to be a perfect square. Who's he a perfect square of?
A.
A. You're looking for the last term to be plus. It has to be plus. Plus a perfect square. What's he a perfect square of?
B.
B. You're looking for this middle term to be twice those square roots products. What's A times B? AB. Is this twice AB? Yes, it is. So what does it factor into? Square root of the first?
Oh, this is,
Keep the sign, it is backwards. It is exactly what I taught you, but it is backwards. Keep this sign plus square root of the last, quantity squared. Okay? And this is what Hayden's thinking about. Remember how when we learned how to square a binomial, we squared the first, a squared. Kept the sign,
twice the
plus.
product.
Twice their product. Their product is AB, so twice that is 2AB. And then plus, remember how we said it was always a plus? Because when you square something, guys, it's always positive. All right, square the last, b squared. There's another one that looks like this. A squared minus 2AB plus b squared. And what does he factor into?
A minus B.
Yeah,
Quantity
A minus B, quantity squared. Okay, so here's what you're looking for. This first term right here, he must be a perfect square. If he's not a perfect square, then you go, oh, he's not special, and then you start factoring it the old-fashioned way, okay? This last term right here has to be plus a perfect square. And again, if he is not plus a perfect square, then you go, oh, he's not special, and then you go on. If he is, you have to make sure that this middle term is twice the square roots product. Okay? Twice the square roots product. So you're looking, and I'm going to show you the easiest way to do it. Okay? I'm going to do 2 of them, and then we're going to move on. All right. So here's the first one I'm going to work. X squared minus 10x plus 25. Okay? X squared minus 10x plus 25. So, is this a perfect square?
Yes.
Of what?
X.
X. So I just write it down right there. Okay? Is this plus a perfect square?
Yes.
Of what?
5.
5. So now, see, it's looking at me now and I don't have to think about stuff, I can see it. Is this middle guy twice their product?
Yes.
So what does it factor into?
X
Well, it's
minus
written
5.
right there, yeah, x, keep the sign, 5. X minus 5 quantity squared. Okay, let's try one more. Gonna make it this one a little bit more difficult. So 4x squared plus 12x plus 9. 4x squared plus 12x plus 9. So I look and I see the 4x squared and I see the plus 9 and I go, uh-oh, this could be special. What is this the square of?
2x.
2x. And what is this the square of?
3.
3. Is that twice their product?
Yes.
So what does he factor into?
2x plus 3.
Quantity squared. Very good. Very good. Yes. Okay, so now we're fixing to start factoring stuff, okay? Remember what you're gonna say when I put a problem down there. You're gonna say, can I take anything out? Guys, listen to me. If you can take something out, it is going to make your problem so much easier and faster to work, okay? So later on, when we do some problems next class, I'll show you how to recognize if you didn't take something out that you should have taken out, okay? So, and the second thing I'm gonna say is it's special. We only have 2 special ones, the difference of 2 perfect squares and a perfect square trinomial. But either one of those we can factor really fast. All right, anybody got a question? Okay, so here we go. This is example 2, and they want me to factor. So here's my first problem. A, x squared minus 49. So I'm gonna factor this. What is the first thing that I should ask myself? Can I take anything out? Okay, so can you take anything out here?
No.
No. The next thing I look and I say, whoa, that's only 2 terms, and they're subtracted, okay? Is that the difference of 2 perfect squares?
Yes.
Yes, so what does it factor into?
X plus 7, x minus 7.
Very good. And would it be incorrect to write x minus 7 times x plus 7?
No.
No, it wouldn't. I just always do the plus sign first. All right, anybody got a question?
Well, I do. So
Uh-huh.
you titled this "Solve That by Factors." What are
We haven't gotten
solving?
there yet.
Oh, okay.
We gotta learn how to factor, right? If you can't factor, you can't solve it,
Okay.
okay? I mean, if they're gonna solve it by factoring, then obviously, if you can't factor it, you're not going to be able to solve it. Later on, in this chapter, we'll learn how to solve things that won't factor, okay? But, we're gonna learn how to solve them first by factoring, because it is the easiest way. All right, so here's your next one. Are you ready? I'm gonna let you do this all by yourself. D squared plus 12D plus 36. Factor. Okay, you ready? All right, so I'm gonna show you how I would do it, and then I'm gonna show you what's gonna happen to you. At some point, it's gonna happen to you. It may not have happened this time, but it will happen, and it's okay. But, all right, so the first thing I say, can I take anything out?
No.
The second thing I say is it special?
Yes.
Yes, it is special. This is the perfect square of what?
D.
D. This is the plus a perfect square of what?
6.
Is this middle twice their product?
Yes.
So that tells me it's square root of the first, keep the sign, square root of the last, quantity squared. Okay? Now, here's what's gonna happen at some point. Some point, you're gonna go D squared plus 12D plus 36. You're gonna be in a hurry. You're gonna go, no, I can't take anything out, so here we go. Factors of d squared are d and d. The plus sign means they both be alike. They'll be like the first guy, plus and plus. Factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 and nothing, 6 and 6. When they stack upon themselves, you're finished, or when they flip-flop, you're finished. Okay? Who adds to be 12?
6.
And then your brain goes, what? Dang, that thing was special. Do you see how long this took me and how fast and easy this was? Okay? So, is it wrong to be written like this? No, it's not wrong. But, okay, this was a lot faster and saved me a lot of time. All right, so here we go. You ready? Here's the next one. C, z squared minus 26z plus 169. Okay, you got it?
Yes.
So, can you take anything out?
No.
Is it special?
Yes.
That's obviously a perfect square. What is this a perfect square of?
13.
13. Very good. So this is the square of z, and this is plus the square, his square root is 13. Is this twice their product?
Yes.
So he factors into square root of the first, keep the sign, square root of the last, quantity squared. Okay? Are you with me?
Yes.
Let's do one more and then we're moving on. The next one looks like this. Z squared plus 8z minus 16.
Not possible.
Okay, let's see. Can I take anything out?
No.
Is it special?
No.
Why?
It is, but
Is it special?
yes. It doesn't follow the rules.
Okay, then it's not special.
Okay, then
Guys, listen to me. This has to be a what?
positive.
A positive. If this is not a plus sign, it is not special. Okay? It is not special. So how long does that take me to look at that and go, yes, you're special and I can factor you, or no, you're out? It doesn't take long at all. I mean, look, if we were factoring, remember these right here? You look at this right here. Is this special?
No,
Why?
because it's not a perfect.
20 is not a perfect square. You see how long that took? Is this special?
Yes.
No,
No,
6 is not a perfect square. You see what I'm saying? Is this special?
Yes.
No, it's a minus sign.
No.
No, 12 is not a perfect square. You see what I'm saying? It takes like 1 second to go, no, you're not special, or wow, maybe you are. Let me look at you for 1 more second and then I can factor you. So I put 2 seconds into it instead of 20 seconds. Okay? So this guy is not special because that's not a plus sign. All right? So that means I have to factor in like this. Do you agree? C and Z. What's a minus sign at the end mean?
They're different.
They're different. So I got a plus and a minus. The factors of 16 are 1 and 16, 2 and 8, 3 and nothing, 4 and 4. Who subtracts to be 8?
Neither. None of them. Not possible.
That's right. There are no factors of 16 that subtract to be 8. Now these are all the factors of 16. 1 from 16 is 15, 2 from 8 is 6, and 4 from 4 is 0. All right? So no, there aren't any of them. All right. So here we go. Example 3. I got 3 more problems. 2 pretty quick ones and 1 a reading problem. Here's what it says. What are the roots of this equation? x squared plus 3x minus 28 equals 0. Yes. X squared plus 3x minus 28 equals 0. Okay? Now, first of all, here's what you need to know. Answers, solutions, roots, zeros, and x-intercepts.
Oh.
All of these things right here are the same thing. Okay? All of these things right here are the same thing. Okay? Just like me, Mrs. Davis, Mom, my dad called me BG. Most people, my friends call me Billy Gay. Okay? So all those, I'm all the same person. Okay? All of these things, they're all the exact same. So when I say, what are the roots? I could have also said, find the answers. Tell me what the solutions to this are. Hey, what are his zeros? Can you find his x-intercepts? Those are all the same thing. Okay, so how do you solve a quadratic? You set it equal to 0 and you factor it. Okay, you're fixing to find out why. You set it equal to 0 and you factor it. So, can I take anything out? Still asking the same questions, guys. Can you take anything out of here?
No.
No. Is it special?
No.
No. 28's not a perfect square, people, and that's a minus sign. Okay? So that means we're busting it out like this right here. Okay? I'm going to list the factors of 28, 1 and 28. I'm going to say this one more time. Okay? Do you have to write these factors down?
No.
No. But if you can't do it, then what do you need to do?
Write them down.
Write them down, because then they're looking at you, okay? If you can't just do it in your head and say, what are the factors of 28 that subtract to be 3? Then you need to go, oh, okay, I better write them down. 1 and 28, what about 2 and something?
14.
What about 3 and anything?
No.
What about 4?
7.
What about 5?
No.
6?
No.
7?
4.
That means they're all there, okay? So anytime that you go and those things flip-flops, that's why I do that, because that says, oh, now I've listed every one of them, okay? I am subtracting them. That's what my cheater sign says. He's telling you what to do. He said, hey, man, you got to subtract. Subtract the factors of 28 to get 3. So, what's my answer? 7 and 4. Okay, and I want a positive, oh, we forgot to do this. X squared factors into x and x. A minus sign at the end means what?
Different signs.
Yeah, plus and minus. I want a positive 3, so who goes by the plus sign?
7.
Yeah, the bigger number. And the other number goes here. I'm still going to go and check plus 7x minus 4x. Why am I telling you this? Because guys, if you don't practice some of the skills you need to use on the test, you won't remember to use them on the test. Okay? So if these two things do not work out to give you that middle guy, you messed up somewhere. You need to go back. Okay? Now, let me ask you a question. If I'm multiplying, now look, I want you to see what this is. Do you agree that this is one number times another number? Do you agree?
Yes.
This is something times something else. These are called factors. Why? Because factors are multiplied together. Tell me the factors of 6, 2 and 3, right? Why? Because 2 times 3 is 6. 1 and 6, because 1 times 6 is 6. All right, so these are called factors. All right, very important words. I'm going to start using some vocabulary here. When I multiply two numbers together and I get 0 as my answer, what do you know about one or both of these numbers?
They're equal to 0.
Yeah, y'all, the only way to get 0 as an answer when you're multiplying is to multiply by 0, okay? So what that means is that either x plus 7 is equal to 0, or x minus 4 is equal to 0, or both of them are equal to 0, okay? So look at this left-hand side.
You lost me
I asked, how would I know, if I multiplied two numbers together and they equaled 0, you said that's what this was, right? Then what do you know about at least one of those numbers?
now. That their x is equal to 0.
No,
Well then,
no.
that doesn't make
That
sense.
this number is equal to 0. If x was 0, this would be x, 0 plus 7 is 7, and 0 minus 4 is negative 4, and 7 times negative 4, he ain't 0. You
That-
see what I'm saying? It says this number is 0. It says x plus 7 is 0. Now, if x plus 7 is 0, 0
Oh,
times,
I figured it out.
do you see what I'm
Yes,
saying?
ma'am.
0 times, I don't care what this number is, it's 0.
Yes, ma'am, okay.
Okay? If this number is 0, 0 times, it don't matter what this guy is, he's
Okay,
0.
I
All right? So now we're going to solve for x. So all you do is take each factor, set it equal to 0, and then you solve for x. Over here, what are you going to do?
move this 7 over.
Yeah, or
Minus
subtract
7.
7 from both sides. And x is equal to what?
Negative 7.
Very good.
Okay, I see what you mean.
Over here, I'm going to add 4 to both sides, and x is equal to 4. Okay? Y'all, that is my solution set. Negative 7, 4. Doesn't matter about the order that you write them in. That makes no difference at all. This is my solution set. This is the way I want you to write it on your worksheet I'm fixing to give you. Okay? Now, I want you to come back and look at some stuff. Okay? The first thing that I want you to look at is, look at this. X plus 7 is the factor. What's the root?
Negative 7.
What happened?
It's the inverse.
It's his opposite, right?
Okay.
He changed his signs.
Okay.
Okay? So x minus 4 is the factor. What's the root?
4. Oh, so
Look at
it's
this.
like how we take P and Q and
Oh, it is exactly like the intercept form. Okay? It is exactly like the intercept form. X plus 7 is the factor. What's the x-intercept? Negative 7. X minus 4 is the factor. What is the x-intercept? Positive 4. Look at there. I could call them x-intercepts if I wanted to. Watch this. What is the only thing that I can replace 0 with?
Y.
Y. So I'm going to replace this 0 with a y, and I'm going to graph this, guys. Okay? Look at that. Where's it going to cross my x-axis?
It's negative 7 and 4.
Another reason you can't use a calculator.
Oh, yeah.
Don't even have to know how to factor, people. Okay? Don't even have to know how to factor. So if I go to y equals, all right, there's my equation right there, right? X squared plus 3x minus 28. I'm going to go zoom 6 because I don't know what's been graphed on here. One, two, three, 4. 1, 2, 3, 4, 5, 6, 7. Negative 7 and 4.
What if it doesn't go through the x-axis though?
We're going to talk about that. We'll get to it. Okay? Now, is that the only way to check this, guys? Could you plug this in and make sure you get 0?
Yeah.
Yes. What is negative 7 squared? What is negative 7 squared? 49. What's negative 7 times 3? Negative 21. And then minus 28. Guess what negative 21 and negative 28 make? Negative 49. There's my 0. You could try your 4. What's 4 squared? 16 plus, what's 4 times 3?
12.
12 minus 28. What's 16 and 12 make?
28.
Minus 28. There's my 0.
I lost what you were plugging it into. That's what
I'm plugging it in this equation right here. The original equation that I gave you. Anytime you want to check something, you always go back to the original equation. Not something you messed with. Okay? Not something that you messed with. All right. So let's try to do another one. Are you ready? This is example 5. All right? Example 5. Example 5 says find the zeros. Is this exactly like that other problem?
Yes.
Y'all, the only thing that's different is look at the way they wrote it. Y is equal to x squared minus x minus 12. What am I going to have to do first?
Factor. Or see if you can take anything out. See if it's special. Oh,
Or
change it to 0.
Yes, change that y to a 0. Y and 0 are the only things that are kind of interchangeable. Okay? So 0 is equal to x squared minus x minus 12. Okay, so now I'm ready to factor. Can you take anything out?
No.
Is he special?
No.
People, 12's not a perfect square. He can't be special. Plus, that's minus sign. All right, so that means we're going to factor him like this. X squared factors into x times x. What does a minus sign at the end mean?
They're different.
Plus and minus. The factors of 12, 1 and 12, 2 and 6, 3 and 4, and 4 and 3. All right, look, here's my cheater sign right here. This last sign tells you what you're doing with the factors. What are the factors of 12 that subtract to be 1?
4 and 3.
4 and 3. I want a negative 1, so who goes by the negative?
4.
The big number, and the little number goes here. Still going to check those inners and outers. Inners, positive 3x, and the outers, negative 4x. There's my negative 1x, okay? Now, listen to this. Listen to me. X plus 3 is the factor. Tell me what the 0 is.
Negative 3.
Perfect.
Negative 4.
All you're doing is what? From a factor to a root, from a factor to a 0, from a factor to an x-intercept, from a factor to a solution, what do? Change the sign. Now listen to me, y'all. That's really important because you're fixing to do a worksheet and all the problems are like that. If you don't understand that, what's going to happen to you?
You're going to get them all wrong.
That's exactly right. Okay? That's exactly right. Do not be that person that's not paying attention right now. All right? So if my factor is x plus 3, my 0, my root, whatever, is negative 3. If my factor is x minus 4, what's my 0?
4.
Positive 4. And this is my solution set, because those are my answers, my zeros, my roots, my solutions, my x-intercepts.
So on our packet we turned in, it had a place for x-intercepts. Were we supposed to write it like that?
No, but I am going to tell you, I wasn't going to tell you today, but I will since you asked, okay? So remember when you got the thing, it looked like this. There might have been a 2 right here, and then it might say x plus 5 and x minus 7. Do you agree?
Yes.
Okay, and I said, and the very first blank says, hey, write your x-intercepts.
Yes.
All right, what is this guy?
Negative 5.
Negative 5. What is this guy?
7.
7. Okay, I do not want this, and I'm going to do it, and I want you to tell me why I don't want it.
Because those are points.
Yeah, y'all, that looks just like a point, and it looks like what you're saying is that the point negative 5, 7 is a solution to this, and it's not, okay? It is not. So be careful about that, all right? I didn't count any of them wrong because I didn't say anything to, but you know how sometimes when I'm grading your papers and I make notes to myself, and I come back and tell you all about little things, that's one of the little things that I have on my notes. Because a lot of kids wrote parentheses around them, and I don't want you to do that. You can do this. At this point, you did not know that.
Okay, so it's not
Okay?
wrong.
At this point, you did not know that these are actually the solutions if I set that equal to 0. Okay? Yes?
I think I put brackets around mine.
That's okay. And if you did put brackets around it, that's perfectly fine. Okay? Even the parentheses, I'm not going to count it wrong. It was just something that I said, hey, we don't want to do this. I need to make sure they know that. All right? Because it just looks funky. Okay. So now I want to work one more problem, and then I'm going to give you the rest of class, and you can work on your worksheet. I'll give it to you in just a second. All right. So this is example 4. Okay? It's another application problem. You are going to see lots of applications for quadratics. Lots of real-life applications for quadratics. So here is this one. It says, a town has a nature preserve with a rectangular field that measures 600 by 400 meters. The town wants to double the area of the field by adding land to the length and the width, the same amount to the length and the width. Okay, so here's what it's saying. It's saying that they have a rectangular field. Okay, they told me that the length was 600 and the width was 400. they wanna double the area, okay? Double the area. How do you find the area?
Length times width.
Length times width. Okay, so they wanna double the area, and they wanna do it by doing it this way. They wanna add so much to the length, okay? You don't know how much it is, but whatever they add to the length, they also want to add that amount to the width. So it's gonna look like this. Do you see what I'm saying?
Yes.
Okay, now I wanna double the area. So let's talk about what's the area of this section that we have? 24
2,000.
and 4 zeros, right?
Oh, yeah, so.
Right? So 6 times 4 is 24, and I got 4 zeros. 1, 2, 3, 4. So 240,000 square yards, all right? 240,000 square yards. Now, if I want to double that area, what's it going to be?
400.
Yeah, 480,000 square yards, okay? 480,000 square yards. Well, let's see, what is this side right here going to be if I increase it that much?
Wait,
What's this whole side going to be?
600x.
Okay, that's the common mistake. Be very careful about that. Okay, because if I said this was
600 plus x.
there, you go. But a very, very, very common mistake. It's going to happen. I'm going to say probably a fourth of the time, kids are going to say 600x. You don't multiply these two. You just add them, right? So I'm going to call it x plus 600, just because that's the way you're used to seeing things when we multiply. All right. So what is this width right here going to be?
400 plus x, or x plus 400.
Okay, so 400 plus x, or I'm going to say x plus 400. So that means that when I work it, the length is going to be x plus 600, and the width is going to be x plus 400. Okay, now is this a quadratic equation?
Yes.
Yes, it is. How do you solve a quadratic? Set it equal to
0.
0 and factor and solve. Okay, so obviously I'm going to need to multiply these things first. I can't subtract that until I know what this is. Okay, so I'm going to say 480,000 is equal to, what's first times first?
X squared.
X squared. The outers give you a plus 400x, and the inners give you a plus 600x. What's that going to be?
1,000x.
1,000 plus 1,000x. And then I have my last times my last. They're like signs, so it's plus. Again, 4 times 6 is 24, and 4 zeros.
So
Now what do I do?
move that 480.
Yeah, I'm moving this guy over here, so I'm subtracting him. 480,000. This over here ends up being 0, but I do it over here, and I get x squared plus 1,000x, and 240 minus 480 is negative 240,000. Okay, so now watch this. Can you take anything out?
Oh,
No.
no.
Is it special?
I don't know.
People, is 24 a perfect square?
Oh, yes. Wait, 24, no.
No, he's not special, and plus that's a minus
Oh,
sign.
yeah.
Okay, so that means we gotta guess and check. Okay, now do I wanna list all the factors of 240,000? I don't really want to. Wouldn't be that big a deal, we could do it, but I don't want to. I want to show you that you can guess and check, and I'm gonna say within 4 to 5 times you'll have the answer. Okay, I'm gonna guess numbers that divide into 240,000, and I want those two numbers to be 1,000 apart. Do you see what I'm saying? They have to be 1,000 apart. All right, so just tell me some place to start. I don't really care. I'm going to say 240, 1, 2, 3, divided by. Where do you want to start? Tell me a number that divides into there. You know one.
600.
600 divided by 600. 400. Are these 1,000 apart?
No,
Do you agree that 600 is too big?
yes,
Okay, so 240, 1, 2, 3, divided by
40.
40,
Well, that's not a,
6,000. He's what? He's too
small.
small, okay? He's too small. So 240, 1,
What
2,
about
3,
300.
300. I'm 500 apart, okay? So I'm getting closer because y'all right here, you're what? 5,960 apart. So I'm saying you're a long way apart. I'm getting a lot closer, but
So do I need to go up or down?
he's still too what?
High.
High. He's still too high, okay? Because I need this to be, these two to subtract to be 1,000. 240, 1, 2, 3, divided by 200.
Oh, that's.
Are those 1,000 apart?
Yes.
Do you see what I'm saying? Okay, so those are my factors, 200 and 1,200. So 200 and 1,200 are my factors. So let's factoring x and x. A minus sign means a plus and a minus. Now, I want them to subtract to give a positive 1,000. So who goes by the plus sign?
The
1,200.
Yeah.
Okay, and the 200 goes by the minus sign. Okay, now listen to what I'm saying. If x plus 1,200 is the factor, what's the root?
Negative 12.
Negative 1,200. Okay, if x minus 200 is the factor, what's the root? Positive 200. Okay, now let's go look at my problem, because y'all look, if this was my problem right here, I'd be like, bam, I'm done. Okay, but it's an application problem. So tell me what that looks like when x is negative 1,200.
I'm confused now.
If this length of this side of the field is 600 yards,
Well, we wouldn't see it.
can I take 1,200 yards off of it?
No.
People, you would be sucked into space in a black hole. It would not be fun. Okay? This answer, do you agree? This answer makes no sense as far as this problem is concerned. Is he a solution? Yes. But he makes no sense in this problem. What about 200? Does 200 make sense? Can you add
Oh, I
200
see.
yards to 600?
Yes.
What would that be?
800.
800? Can I add 200 yards to 400?
Yes.
What would that be?
600.
800 times 600. What's 6 times 8? 48.
Oh.
And 4 zeros. So this would be the dimensions of my field, and this would be how much?
So you only use one of those?
Most likely you're going to only use one. Okay? Most likely one of them is not going to be applicable. It's going to,
Well, wouldn't it have gone
Eliminate
through quadrant
itself.
1? It would, 'cause it
yes,
was
that's
negatives.
exactly right. Okay? All right. So I'm going to pass out your worksheets, and then you will only have 5 minutes. But I'm going to say in 5 minutes, y'all could probably work the first line. Okay, where are we here?
So what are the two answer